everything really, all three processes. The worksheet we have covered conduction, convection. So now we are down to radiation. Definition of radiation as shown. Do your marking and corrections. So the key thing about radiation is that heat is transferred without the need for a medium. So you have said that medium refers to like your air, your solids, your liquids. So the other two types of thermal energy transfer will be conduction and convection, which requires a medium. So how is it that radiation does not require a medium? The answer is because it is in the form of infrared radiation, which is a type of wave. So waves can travel in vacuum, like your light rays. Your radiation, this infrared radiation is also a type of wave. Your UV rays, they all can travel through space in a vacuum. So part 2, question 2. You hold a hot iron next to a person's hand. What are the processes by which thermal energy from the iron reaches the person's hand? So what are the two ways that you all have? Conduction or convection? You think about it, it is held next to a person's hand. It is not in contact with the person's hand. So conduction or convection? Why conduction? You say conduction or convection? Convection. Yes, you need to know the medium. In this case, the medium is air, which is a fluid. So, because the air particles, they are very far apart, it takes a long time for conduction to happen. Because conduction is when they vibrate and they hit each other, right? Then they transfer the energy. In air, the spacing between the molecules are very far apart, so conduction doesn't take place easily in air. So our answer will be convection, in the form of convection currents. And the other one will be radiation. Cannot. Air is a poor conductor of heat. So we don't expect air to conduct heat well. And the reason why you're feeling the heat from the iron is because of convection currents and through radiation, infrared radiation. Yeah. Who is the other person? Another one that you mentioned? Mas is in Mr. Tan's class. Okay. We are doing 8C. If you haven't done it, just go to the back. If you've done it, sit down and do your corrections. Now, which process is faster? Radiation. It is almost instantaneous. Your light rays, they travel at a speed of light. Just like your radiation, they also travel at a speed of light. 3 times 10 to the power 8 meters per second. It is the fastest. You don't have to wait for the particles to hit each other, to travel. You don't have to wait for the change in density to happen. Radiation is almost instantaneous, but it is not instantaneous. There is still a speed. Okay? Then we have characteristics of absorbers or emitters. So yesterday we covered that dull and black surfaces, they are good absorbers. At the same time, they are also good emitters. But when we discuss about an object, we usually only talk about whether they are absorbing or whether they are emitting. Depends on the context of the question. Okay? Now, color of surface. If it is a good absorber or emitter, I just mentioned that it will be black. Black. Texture will be dull, rough. Then a poor absorber will be shiny. Okay, the color will be shiny or silvery. White. White is not as a good reflector, so no, should put it as shiny. Then the texture will be smooth. me restart this. Then what is the next question? Explain the following observations. The surface of a black car is hotter than a white car after both have been parked under the sun for half an hour. Okay. What is the process we are talking about over here for the car? Oh man. Which is the process that we are... So which is the process? 4A. Convection, conduction, or radiation? Okay, radiation. Because they are now talking about surfaces. Okay, then why is it that a black car, the surface is hotter than a white car? Why? Okay, I've got two answers. Xiaowei one is black is a better conductor of heat, and Moaz is? Okay, he says that dull and black surfaces, they absorb, is it? Did you say absorb? Yeah, they absorb radiation better than the white and shiny surfaces. Did anybody have any other answers? Anybody talk about emission? Nobody, Okay, yes. Moaz's answer is correct. Xiaowei's answer is almost there, but he said conductor. So do you say conductor or absorber? Yeah, then if you say absorber, you'll be correct. If you say conductor, then it's wrong. Because conductors will be referring to conduction, the process of conduction. Okay, never mind. Oh man. I'm sorry, it seems to be problems over here. Okay, so yes, there are better absorbers. We don't need to talk about emitters. We don't need to say that it is a better emitter. Because in this case, the context is about them absorbing infrared radiation. So the surface will gain thermal energy at a faster rate and become hotter. Yesterday, I showed you the setup. One thermometer is wrapped with shiny aluminum foil. The other thermometer is wrapped with the dull side, the blackened side of the aluminum foil. So the one that is dull and black, it absorbs heat faster. Then the temperature in the thermometer is shown to rise faster. Okay, then using the similar concept, we can now explain 4B. Shiny teapots, they keep tea warm for a longer time than black teapots. So why? Okay. The rest who have done it, what do you all put as your answer? Same as? Same as A. Same answer as A. Gaius, can you please read out your answer? Oh, poor absorbers of heat. Okay then. So? Do you all agree? So Gaius, you talk about absorbing of heat again, right? Right? That was the keyword you had inside, right? Do you all agree? Is the context about absorbing or emitting heat? We are trying to keep the tea inside warm, right? So we are concerned about whether which teapot emits heat faster at a faster rate. So we should be concerned about which is a better or poorer emitter of heat, not which is a better absorber of heat. Understand, Gaius? So that's why I say the context is very important. The answer for part B will be shiny teapots are poorer emitters of heat. Of infrared radiation. the heat in radiation, we call it infrared radiation. So shiny teapots are poorer emitters of infrared radiation than black teapots. So it's very similar to the first sentence in part A. We just change the words. So one last time, shiny teapots are poorer emitters of infrared radiation than black teapots or black surfaces. Then the second sentence is, the surface of the shiny teapot emits thermal energy at a slower rate. Yep. Okay, then there's the second part. So the surface of the shiny teapot emits thermal energy at a lower rate, thus keeping the tea warm for a longer period of time. Anybody needs me to repeat? Okay, first or second sentence? Okay, both. First one, shiny surfaces are poorer emitters of infrared radiation than black surfaces. Second sentence, the surface of the shiny teapot emits thermal energy at a slower rate, thus keeping tea warmer for a longer time. Right? So worksheet 8D. Now, which material is the most suitable for filling the gaps between brick walls of houses for the purpose of heat insulation? What will you choose? Pebbles. Why? No, then there must see part 2 they ask you to state why. Felt is like a type of fabric. Okay? It is the purpose of filling the gaps of the brick wall is to insulate. That means you want to prevent heat being transferred from conduction. Concrete is a dense solid. You don't have air pockets in concrete. Whereas in felt, like your cotton, like your winter wear, you have feathers inside, you have down inside, you have cotton. All these, they trap air. And air is a good insulator of heat. So whatever body warmth that you have, it is trapped under your jacket. Just like this, they want to trap the thermal energy in the house, so they need to have insulators inside. In this case, they'll use felt. Sorry? Pebbles, they don't trap air. Then if there is air in between them, then we might as well not put anything, right? You see, between the choices of pebbles versus don't put anything. Don't put anything, even better, right? So that's why pebbles will be out lah. And felt, in this case, they trap heat in between the fabric. Okay? Now, next part. This is a vacuum flask. So yesterday, I told you to read up on the different components of the vacuum flask. Then you have glass walls. There is vacuum in between them. It minimizes the loss of thermal energy by conduction and convection. Why is that so? Why is this sentence correct? Why is convection and conduction minimized by vacuum? Yes, there is no medium in vacuum. So your conduction and convection cannot take place. They must have a medium in the form of particles to happen. So once you have vacuum, you don't have conduction, you don't have convection already. Then the glass walls, they are silvered. They make it shiny so that you minimize the loss of thermal energy by radiation. Shiny surfaces, they are poor absorbers. They are also poor emitters of infrared radiation. And finally, last page, because you don't have to do worksheet 8E. The process by which the heated water rises from the boiler to the hot water tank is by convection. Rises upwards. Your convection current. Okay? Because the spacing between the molecules is larger, they take up a greater volume, they are less dense, so they rise up into the boiler. Then part B, is it through pipe P or Q does the heated water rise? Will be pipe P. So like I just mentioned, expand, less dense, rises. In fact, between the expand and less dense, you can put in an arrow and say that volume increases. Okay? Expands, volume increases, then it becomes less dense, so they rise through pipe P and flow into the hot water tank. Before that, you need to talk about the volume first. Volume bigger, density smaller. Greater space in volume. Greater space, then you talk about volume first. Okay, greater space, greater volume, less density. So just add in that part. Okay, then part C, describe the function of pipe R over here. Okay, copy this down first, then I'll explain. Yes. If there's no opening, the pressure will build up, yes, because when it is boiling up, your water becomes water vapor, right? Then your gases will take up a lot of space. Because they take up a lot of space, and there's little space over here, if you cap everything, if you plug everything, there's no place for the gas to escape. So the pressure will build up, higher pressure, and you know what will happen in the end? And then it will explode. Okay, so but in this case it won't happen because there's an opening over here. And the function of pipe R is such that when the water expands as it is heated up, it can overflow into this basin over here. Okay, can you imagine if the water all boiling and expanding and then your hot water tap is off, then all the water will have to overflow somewhere. And this is where they overflow into, back into the basin, then it will go back into the water tank. And the convection current will resume over here. Okay? Any questions for worksheet 8D? If they are not, you have 10 more minutes, 7 more minutes. I want you to start work on your TYS